Right. So, construction industry in Pakistan. Okay. Predominantly, we have three systems in which you can categorize structures and buildings, to be honest: steel, concrete, and and this we have done. Most of you have got it right. You're almost there. What kind of masonries we have? Load bearing, confined. The जो ज़्यादातर पाकिस्तान में यूज़ होती हैं वो हमने डिस्कस कर ली हैं. We stick to Pakistan because you will be. I mean, this is the concentration area. Now we come to concrete. So anything above 3 stories. This is masonry has a limit of 2 stories. An added plus maybe a half story जो आपको जिसको आप लोग मम्टी कहते हैं. You can put that on, but predominantly 2. And if you have a basement, so masonry, अगर आपके पास basement है, तो you can have 3. If you're just ground plus 1, 2.5. I would say 0.5 because you have this small mumty going upstairs. इससे ऊपर you can't go in masonry. There are limitations, seismic limitations, there are construction limitations, and there are material specification limitations. So if you have a building now coming up, it is not important if it is a house. ये याद रखना बात. जरूरी नहीं है कि वो घर है तो वो masonry ही होगा. What governs is the number of stories. So now if you have anything above 3, that's your good friend concrete. So I would say 3 to 80 stories is mostly concrete. Do you know the word indigenous? क्या मतलब है इसका? We are very good with concrete. We have good experience with concrete. हमारे यहाँ सीमेंट बनता है, हमारे से यहाँ सीमेंट एक्सपोर्ट होता है, millions of tons. We are very good with concrete. Unfortunately, we don't have much steel. Because what in steel manufacturing you have iron ore. This goes through a process of smelting, and then you convert it into a billet, and then you roll sections out of it. You can have I section, you can have rebar, you can have C section, you can have numbers of sections that you can get. Unfortunately, the quality of our ore is pathetic, and we don't have that kind of a mill which is now financially viable in Pakistan कि हम अपना स्टील खुद प्रोड्यूस करें. फाइनेंशियली वाइबल इसीलिए नहीं है क्योंकि अब हमारे यहाँ बिजली की जो प्राइसेस हैं, जो हमारे हालात हैं, हमारी पाकिस्तान स्टील मिल अमूमन लोग समझते हैं करप्शन की वजह से फोत हुई है, बट नो, इट डाइड आउट बिकॉज हमारी जो कॉस्ट ऑफ प्रोडक्शन थी उससे 10 रुपये सस्ता चाइना का स्टील हमें डोर स्टेप पे पड़ता है. सो इट हैड टू शट डाउन. इट वॉज बिकमिंग वेरी वेरी अनइकोनॉमिकल. सो minimum use of steel and maximum use of your indigenous material is concrete. So you have like 80% concrete और उसमें 2% 3% स्टील लग जाता है, या लेट्स से आई से 5%. ठीक है, 95%. सो ये हमारे पास अपना होम ग्रोन मटेरियल है, हमारे पास अबंडेंस है इसकी, वी एक्सपोर्टेड. दिस इज द ड्रीम कम ट्रू कॉम्बिनेशन. सो वी हैव RCC देयर फॉर decades and decades and it's still going on. And then होता क्या है कि when you keep on doing this construction you have homegrown talent. Now every Tom, Dick and Harry can do concrete structures. You don't need a license. You can become a contractor. Shuttering लगाई, सरिया बांधा और 5-6 स्टोरी की बिल्डिंग एमी बना दी. You barely find any contractor जो कि मतलब 30-40 हज़ार एमी लोग बनवा लेते हैं, किसी कंपनी को हायर नहीं करते हैं, which is actually very detrimental to you guys financially. कोई भी नूरा उठ के बैठता है और कहता है जी मैं डिज़ाइनर भी हूँ, मैं ये भी हूँ, और ठप्पे लगवा के किसी आर्किटेक्ट से जमा कराया और शुरू हो गया. This hurts you guys the most. Okay? Khair, coming to the topic. Let's not drift away. So, concrete is anything above. This could be a question in the exam as well. 3 to 60 stories in case of Pakistan only, not internationally. ठीक है? हर मुल्क के अपने मसाइल हैं. हमारे जो मसाइल हैं, जो हमारा जो चैप्टर है उसमें हमें 3 to 60 स्टोरी ये फाइनेंशियली वाइबल पड़ती है. नाउ फाइनेंशियल वायबिलिटी भी एक क्वेश्चन मार्क. I have a building which I have to rent out and it generates 1 crore rupee for me in a month. Okay? So construction time for that building 1 lakh square feet. There are buildings that do that, madam. The one I am sitting in the office, this guy makes 1 crore rupee a month rent mein. So yeah, don't nod your head. It happens. There are a lot of projects like that. अगर वो कंपनी 1 करोड़ रुपया पर मंथ बना रही है, अब उसकी कंस्ट्रक्शन अगर आप कंक्रीट में करें और 4 साल में हो, so he's obviously going to lose a lot of rent. What if that building comes up on the ground in 6 months? मैंने कहा ना फाइनेंशियल वायबिलिटी भी एक एब्स्ट्रैक्ट है. What if that building comes up on the ground in 6 months? He's going to make what? So he's going to make 1 crore into almost, let's say, 42 months. So that's 42 crore rupees. Now that's financial viability. And when you want rapid and speedy construction, you have steel structures. My favorite, all-time favorite, actually. Yeah, what happened to my pen? This guy. Okay? So the steel structure is predominantly the best so far for rapid construction. मोस्टली किस काम के लिए पाकिस्तान के चैप्टर में यूज हो रही है, वील डिस्कस दैट. बट सिंस पाकिस्तान में इतने फाइनेंशियली वायबल प्रोजेक्ट्स अभी यू सी गो आई शिफ्टेड टू इस्लामाबाद 1988 and since 1988 in 2024 there are only 16 buildings in my lifetime that I've seen come up in Islamabad. 16 नहीं तो 26 होंगी. यूफोन टावर होगा, सेंटोरस होगा, this and that. So no, Pakistan we have a bigger problem with housing. That is why I focus and start with masonry. Housing is a bigger problem we have in this region. So anyways, so you have steel structures. If I want to ask you some questions. So questions जो है वो ये है. Now it's a scenario. You are the architect. Scenario number 1 जनाब, 3 story residential. क्या चूज करेंगे? Masonry. The contractor says this is going to come up in 9 months. The client says I want a building in 2 months. What do you choose then? Steel structures. So steel structure will give you in 2 to 3 months maximum. I can do this in 2 months. So concrete, is there any validation here? Do you need concrete here? No, you don't. I'm going to give you scenarios कि भाई ये scenario है. Structural system suggest करें client को. ठीक है. One additional benefit that steel brings is you can have very, very, very enormously large spans in single story buildings. So you can have this going up to, actually, if this is a pre-engineered building, I can probably go up to 300 feet. So if you have a space frame, 3-dimensional truss, you can probably go up to 600 feet. You can't do that in concrete. Why? Why? It becomes so heavy itself. It becomes so bloody heavy itself कि वो अपने self load में ही उसका problem शुरू हो जाता है. So you can't have. So a lot of final year students come to me and say कि सर ये हमने ये बना दिया है, and then there are multi-story on it, and this span जो है मेरी parking disturb हो रही है, तो this is 60 feet. Okay? Unfortunately, in doing this in concrete is very, very financially unviable, very difficult to pull off. And one more rule I want to tell you is that कि beam का जितना span होगा, you know what a span is, right? Let's say ये beam है. अगर इसका 60 feet span है, एक rule of thumb है, hard and fast नहीं है, this will be 60 inches. So if, let's say, if I measure this looks like 35 feet. This looks like 35 inches. Or say like 36 inches. 3 foot का beam है ये. Always remember that when you're sizing your projects, when you're doing your thesis, when you're doing all of that, जितना span है steel का, beam का concrete, do that. Now in steel, you know, you can actually pull this off with 60 divided by 3, 20 inches. So steel has its benefits. It comes at a higher price. They're expensive than concrete structures, which is actually changing here in Pakistan now, which is very weird. अब ये सस्ते होते जा रहे हैं because concrete is expensive. Concrete के जो materials हैं, they are becoming expensive. Anyways, so this was an introduction to why and where we have to choose concrete structures. 99% buildings जो आप लोग करेंगे, जो 3 story से ऊपर होंगी, 4 story, 5 story, वो क्या होंगी? Concrete, RCC, not concrete. There is PCC. What is PCC? Plain cement concrete. What is absent in it? and RCC obviously is reinforced with steel bar. So here we go then. Blah blah blah, and here let's go. So you have an RCC. It's a construction method that includes a network of columns, beams that are used to transfer load coming on the structure to the foundation successfully. And if you, in terms of FBD, what is that? In terms of FBD, if I write this line to you guys and I say कि इसकी diagram बनाएं जो ये क्या है, can you diagramize this thing? Read this out loud, pull out your papers and pencils and diagramize it. Diagramize this statement. It is a construction method that includes a network of beams and columns that are used to transfer the load on the structure to the foundation successfully. Hence, achieving what? Static equilibrium. You want the building to stand on the ground. Make a diagram. In terms of free body diagram, 3 story की building है. क्या कह रहा है वो? अंग्रेजी उसकी जो है उसको ट्रांसलेट करें जल्दी से. हाँ जी. हेलो हेलो. नहीं, मैं नहीं आया ऑफिस. मैं भी लेक्चर ले रहा हूँ. तुम्हें मैं 10 दफा बता चुका हूँ सुबह से. राइट. सो जो वो कह रहा है, इट्स वेरी सिंपल. इट्स ABC. You have a network of slabs and beams and columns to bring the load. लोड किस चीज का? लाइव लोड, डेड लोड, सोलर पैनल का लोड, फिनिशेस का लोड, एवरीथिंग टू द substrata or the ground. Yes. So if I draw a free body diagram, this will be something like this. Right? You have load here, load here, load here, load here, and eventually a reaction here. What kind of support will this be? Fixed? Who said fixed? Raise your hands, please. ये क्या होता है? It's either yes, or it's black, or it's white. How many of you say pin? Excellent. Very good. Pin भी हो सकती है और fix भी हो सकती है. It depends on the engineer how he's going to design it. How do you know this? Even engineers don't know this. I've met engineers जिनको ये भी नहीं पता कि pin भी हो सकती है, fix भी हो सकती है. Good. Graduate होके आ जाओ मेरे पास. In RCC frame structure, the load transferred from the slab to the beam. Slab to the beam. ये slab है. The load is transferred from the slab to the beam, from the beams to the column, and to the columns down to the ground and the foundation. ठीक है? The steel wall utilizes, इसको छोड़ दें, ये this is the same things that I've read about, जिस पे हमने पूरा लेक्चर किया हुआ है कि रीबार का फंक्शन कंक्रीट में क्या है. क्या है रीबार का फंक्शन कंक्रीट के अंदर? क्या है? यस, एक्सीलेंट. टेंशन होनी मत आना मेरे पास, तुम आना मेरे पास. मैं भी चूज कर रहा हूँ हेड हंटिंग में लगा हुआ करने. ठीक है. Rebar will, what it will do is it will cater for the incapacity of concrete to take tension. So it will be there, it will be present there to help concrete take all the tension. It's the husband in the married life, okay? Takes all the tension. And the compression is concrete. उनकी जरूरत नहीं, सच यही है. Components of RCC frame structure. You have a roof slab. This is it. इसमें इससे अलावा और कुछ है ही नहीं है. ये डायग्राम रट लें, ये बहुत इंपॉर्टेंट है. Roof slab. You know how to detail a roof slab, right? You know how to detail a column. The beam is left. क्या beam कर लिया हमने? कर लिया. So you know how the reinforcement works, how to detail them, how to read a drawing. I will give you a complete set of drawing in exam perhaps, कि मुझे ये लिख के दें कॉलम में कितना स्टील है, बीम में कितना स्टील है, L/4 पे कितना कटा हुआ है, नेगेटिव क्या है, पॉजिटिव क्या है. सो मुझे ये इस तरह की कैपेसिटी निकाल के इस सेमेस्टर से निकालना है कि आप लोग स्ट्रक्चर की ड्राइंग पढ़ सकें. यू नो व्हाट, एग्जाम विल बी फार अवे. आई विल गिव यू गाइस अ क्विज. आई हैव सीन यू फर्स्ट टाइम आई यू हैं. So you have these, I would say 7 elevator shaft को भूल जाएं. This is nonsense. You don't need this as a structure. So these are the components of a concrete building: beams, columns, slabs, foundations, and reinforcement bars. That's it. Forget both. Okay? जो प्राइमरी एलिमेंट्स हैं, लुक अराउंड, डू यू सी देम? वेयर इज द स्लैब? ये भी है. दिस इज द स्लैब. जरूरी नहीं ऊपर ये हो, ये भी स्लैब है. वेयर आर द बीम्स? वेयर आर द कॉलम्स? कॉलम नहीं है. वेरी गुड. शुभ बाबे ने खड़ी की हुई बिल्डिंग, ये कॉलम्स नहीं है. वेयर आर द कॉलम्स? Oh, I'm sorry if you believe him or you're a follower, no offense. Well, maybe, yeah. It's a weird word. But that is a column. See? That is a column. That is a column. These are, and then I'm sure there is a shear wall. 99% जो concrete की shear walls होती हैं, वो होती हैं elevator shaft में. You can't put a complete blob of concrete wall in the middle of the building anywhere. So ideally, they're on shear walls or in the elevator shafts, or they can be out somewhere which you can't see. This can be a shear wall. I can choose this wall to be a shear wall. Shear wall की existence सिर्फ और सिर्फ later loads के लिए. And earthquake is the biggest enemy of concrete buildings. Okay? And shear wall is की existence जो है, it is only and only to cater for the seismic lateral loads. विंड कंक्रीट को कुछ नहीं कहती. आज तक कोई कंक्रीट की बिल्डिंग उड़ी नहीं है, सब जलजिले में गिरी है. स्टील की बिल्डिंग्स का प्रॉब्लम है उड़ना, कंक्रीट की बिल्डिंग्स नहीं. क्यों है? स्टील की बिल्डिंग उड़ती क्यों है? एक्सेलेंट, वेल डन, नो वंडर यू माय फेवरेट स्टूडेंट. कंक्रीट has a very high dead load. Its density, its volume. Steel structures are, and write this down, 5 times lighter than concrete structures. 3 to 5 times lighter. So if you're a lighter building, your enemy would be wind, not earthquake. And for earthquake, if you go high rise, that's a different story. For concrete, your biggest enemy is seismic load. When I've designed all the buildings I've ever designed, the biggest problem comes when I apply earthquake forces. Okay? So shear walls उनके लिए होती हैं. Beams. We all know what beams are. I think we have discussed them so much. They are the horizontal load-bearing members. The one which are red in this SketchUp model that I created for you guys are beams. So the beams can be on they have to be on every floor. Can you eliminate beams? How many of you think yes? Excellent. And then what do you have? Flat slab, which we had a little bit of run down through. उसको भी अभी इन्हें देखना है अभी. हाँ? So you can take out beams that turns it into a flat slab. क्या हुआ है? उनसे बोलो ना जरा. I'm just kidding. Just go. You don't have to say it यार. जल्दी आओ यार. Main beams and secondary beams, let's not get into that. Right now, beams are beams. What kind of beams do we have in a building? We have predominantly three kind of beams. A, cantilever beam. छज्जा. छज्जा जिसे पंजाबी में नहीं कहते, बाहर निकला होता है. छज्जा. Forget that. It's a cantilever beam. छज्जा भी यहाँ. I can give you an example. Garter. Yeah, but we are talking. We are predominantly right now in concrete. So let's not go into that. वो हम steel structure जब आएंगे तो फिर we can discuss your गाँव वाला गाँव घर. Right now concrete. Okay. And mostly I don't think there is any concrete in गाँव वाले घर. Is there? अच्छा. You live in an advanced गाँव there. So anything protruding out, slab or beam is a cantilever beam. So my arm right now is a cantilever beam. Okay. Anything protruding out of the main structure. Do you see any cantilevers over here? You see? Can you see through the wall? You don't see any cantilevers over here. You can't. अगर ये इस अमूमन जो है water percussion के लिए विंडोज के ऊपर थोड़े थोड़े वो निकाले हुए होते हैं ताकि पानी खिड़की के और कंक्रीट के जॉइंट में ना जाए. Those are cantilever slabs. Cantilever slabs. Cantilever beams are different. If this beam running through is going from here and going out, is that a cantilever? That will be an overhang, which is the third number. If you're continuing a beam from inside to the outside, it's an overhang. Lots and lots of architects confuse cantilever with overhang. Beams can be very difficult to create overhangs. Cantilever beams बनाना बहुत मुश्किल होता है because they are not resting anything and you need a seesaw. Overhang is a seesaw. So if you have, let's say, 1 ton of concrete here, and if I balance it with 3 tons of concrete here, then I can easily overhang. It's nothing. So it becomes an easy job if I have a beam coming from this. अब इधर मुझे कोई आर्किटेक्ट के मुझे 15 फुट का कैंटिलीवर बाहर चाहिए, आर्किटेक्चरल कैंटिलीवर, I can easily do it. I'll just take these beams, I will overhang them. आगे उसका counter weight है, मैं calculate कर लूँगा. Let's say that comes to 30 tons. If I have this slab and this thing 30 tons, game over. It's like a typical seesaw, and that will be your overhang. Okay. Simply supported beam क्या होता है? Do you see simply supported beams here? Do you? मुझसे पूछ रही हो तुम, मैं तुमसे पूछ रहा हूँ. वो तो मैं बता ही दूंगा एंड में, बट आई एम आस्किंग यू गाइस. What's wrong with my pen today? Right. So simply supported beam is a simple beam. It's here. It's here. It's a simple beam, and it will be pin supported on both the ends. It will be pin supported on both the ends. It will not have an overhang. It will not have a fixed support. Just like this. What kind of support do you see here? Yes. So if I look at it in terms of an FBD, this is a fixed support. Now, the technical question is, why do I need a fixed support here? Because it has a load here and it has a D here. So force and D, and whenever you see force and to D, it's a bending moment. Now, does the pin support resist a bending moment? Does a roller support resist a bending moment? The only support that does is a fixed support. So I need a fixed support here. Same is for this. If I create a bending moment diagram for this, it goes something like this, something like this. I need a pin support here. I need a pin support here. These essentially are pin supports. So yes, this is a simply supported beam. Okay? don't delve into much. You should just understand the concept of a simply supported beam. Okay? So, is this tabletop simply supported beam?
Yes.
Is it? Let's do an experiment. Come here. हैं? भाई साहब क्या हुआ है? इतना इधर बैठ आके बैठो ना, यहाँ आके बैठो मेरे पास. टॉयलेट से होके आएगा, मजाक थोड़ी है. मुंह सिर्फ करो, बैठ जाओ इधर. इधर इधर सेंटर ऑफ द टेबल. इधर सिट. तशरीफ उधर मुंह करें. सिट हियर. Yes. So now we have a force and we have a D. कितना वजन है? 15 किलो. मोटे हो गए. So 55 kg multiplied by 2 feet is what? 110 kg for bending moment. Is it resisting? It's resisting. So it's what kind of a support? Fixed. अगर ये पिन है तो मोमेंट सपोर्ट कैसे देगा इसको? कहां से पिन है? यहां से पिन है. तो अगर पिन है, लेट्स से आई अज्यूम, अब तो तुम ये स्लीव मत देना. इफ दिस इज अ पिन एंड दैट इज अ पिन, कैन अ पिन टेक मोमेंट? नो, इट कैन नॉट. इट्स लाइक अ हैंडल ऑफ द डोर. ही शुड बी इन द फ्लोर. फिर बन गया हैंडल लाइक अ डोर. ही शुड बी इन द फ्लोर. ही इज नॉट. Why? Because the moment he is creating, this load is creating, it's being resisted. And when you have a moment resisting support, it's a good. Thank you so much for your participation. Please. However, is this now a simply supported beam or not? Why? Why? Yes, that was the theory of the thing. These are fixed supports. Simply supported beams do not have fixed supports, they have pin supports. So the way structures work then is, अगर ये fixed support है, तो सवाल ये है, प्लीज पे अटेंशन. सवाल ये है कि अगर मैं ये कह रहा हूं कि ये जो बीम्स हैं, ये जो बीम्स लगे हुए हैं, ये मोमेंट नहीं ले सकते, क्या ये बीम्स मोमेंट ले रहे हैं? लोड नहीं है इन पे क्या? क्या ये स्लैब, लेट मी डिजाइन दिस राइट नाउ, ये बिल्डिंग यहां खत्म हो गई, ये वो वाला एज आ गया, ये वाली दीवार ये आ गई, एंड आई एम श्योर दिस बीम इज गोइंग ऑल द वे फ्रॉम हियर टू देयर, राइट? इज दिस बीम टेकिंग द बेंडिंग मोमेंट और नॉट? It is. Then is it a simply supported beam or not? Here is where I get to confuse you. Yes, it's a simply supported beam, but it is resisting moments. Why? Because this is exactly when you do this, bring a seesaw in your mind. It's a seesaw. ये जो लोड इधर है, ये लोड उसको बैलेंस कर रहा है. ये seesaw है ना, ये पिन होता है, यहां लोड होता है तो ये नीचे चला जाता है, यहां लोड होता है तो ये नीचे चला जाता है. इफ बोथ द पीपल आर एट द सेम लोड एंड द बेंडिंग मोमेंट इज इक्वल, इट क्रिएट्स ए इक्विलिब्रियम. कंफ्यूजिंग क्या? तुम गलत तरीके से आई. जवाब एंड में ठीक था, बट आई वांटेड टू कम ब्रिंग यू लाइक दिस. अभी नहीं, अभी अंडर कंसिडरेशन है. मेक सेंस? 50-50 50-50 हो गया, ठीक है, कोई बात नहीं. Even if it is 50-50, we'll come back to this again and again. Sit up straight. ये क्या तरीका है? मुशायरे में आए हुए हो? क्या है? क्या हुआ चेयर को? अच्छा अच्छा. Sorry, I have a problem in my hearing. I was near a very big bomb blast once. So yeah. Adventures of my life. So now we have a fixed. Please, you don't have to ask. You can leave the class and come back whenever you want to. for 5 minutes. Dentist ke pehle aa jao. So we have a fixed beam, we have a continuous beam. You can look them up, you can understand them. There's not much variation in them. Huh? We've gone through this detailing process, top bars and bottom bars and the shear rings. Why do we have shear rings? सर तो तुम ऐसे हिला रही हो, तुम्हें ऐसे इसलिए समझ आ रही है. क्या होता है? I know what they are. Keep seated. I know what they are. But why? Why do we have them? To keep them intact. You can't. मतलब आपने अगर pouring की नहीं है तो ऊपर की जो rebar है वो ऊपर कैसे रहेगी? So you need these bars. You weld them or tie them with a wire, something of the sort. But then they have a structural role as well. They resist shear forces, जो कि हमने ignore कर दी हैं इस class में. I don't want to get into shear forces. They're a bit tricky to understand. They have a role as well. Okay, just write that down, just for the heck of it. Shear bars are present in the beam primarily to resist shear forces. They are also called hanger bars, hence providing or facilitating. Why are you not writing? Are you new in the class? Shear forces. They will primarily resist shear forces, but they are also called hanger bars. तुम क्यों नहीं लिख रही हो? किसके पास है? तुम्हारे पास अपनी कॉपी नहीं है? तुम्हारे पास अपनी कॉपी नहीं है? तुम्हारी कॉपी कहाँ है? It's like I'm teaching 3 क्लास के बच्चे. मेरी कॉपी उसने ले ली मैम. कहाँ है तुम्हारी कॉपी भाई? Take it from her. Write it down. एक कॉपी में तुम दोनों लिख रहे हो. थोड़ा सा वो पुराना लेक्चर अपनी कॉपी पे लिख रही है और ये कॉपी मेरी उसके पास है. मैं इस वजह से लिख सॉरी आई ट्राई मी अगेन प्लीज. तो जब मैं पूरा लिखवा दूं अगर तो वो उसके बाद भी तो लिख सकती है कि नहीं? कितना है? 60-70. प्लीज गेट टेस्टेड. डू. जिंदगी आसान हो जाती. बंदे को पता लग जाए ना वो डफर है तो फिर काम भी डिफरेंट करने चाहिए उसको. आर्किटेक्चर में डफर नहीं चलते. ओके समझ आ गई? अब लिख ली है या अब उसका लेके तुम लिख लो. वाह कहानियां कसम से. Anyways, so primarily they present to resist the shear forces. However, they're also known as hanger bars to facilitate the fixation of the top and bottom bars and keep them intact in concrete. लिख रही हो? Good. Facilitate. Facilitate. Facilitate the fixation of the top and bottom bars. You can do your own English here. So these are the ones that are going in pegs, the perpendicular, the bars or the main bars. We've studied this, right? So main bars and hanger/shear bars. So yeah, these are the components. Let's not get into that. Components of an RCC, explain it closer. No need to understand this. Let's come to the columns now. Okay. Columns are the important structural member of the framing building. Why would I write that line? So stupid of me. Yes, they are. They are the vertical members. So beams are essentially, and columns are your vertical members. So the slab divides load on beams. Beams put them on columns, and then columns take them down on the ground. And that's how you raise your building. I mean, very simple. If you ask me, structural engineering is so simple. It's basic equilibrium and equations and mathematics. It's not a difficult job. Vertical okay, design of the column is more important than this beam of slab. This is because, yes, this is very true. If your beam fail, let's say, who is talking? Is it you under the mask? Don't. So if your beams fail, what will happen? Will the building collapse? Will the building come down? Let's say 10 story ki building hai. If this one particular beam collapses, yes, it's going to redistribute the loads on other beams. And the building will not collapse. But what if a column collapses? Absolutely. Then you are in big trouble. I have a lecture I delivered on failure of structure collapse mechanism. But since you guys are maybe next semester, if I see you guys, अमूमन मेरे साथ यही होता है कि पहले सेमेस्टर के बाद आधे बच्चे जाके शिकायत लगा रहे हैं सर बहुत डिफिकल्ट है किस बारे में क्या कह के आई हो Look at this. Look at this. This is Margala Tower. I was assistant inspection when this building came down. I recently graduated from Texla, and the professor who I did my thesis with was a PhD doctor in structure collapse mechanisms and this and that. So we had a good friendship. जब ये ज़लज़ला आया 8 अक्टूबर को 2005 में, I think you guys were there. No, most just born in Pampers, yeah. Pooping and crying. Yeah, yes, sir, I was pooping and crying. Point well taken. So, anyways, let's discuss that. Let's invest some time in that. Who was there and who was not. Thank you. This is the only time you're giving some attention to this class when we're discussing Pampers and stuff. Anyways, so when I was there, I took some pictures and there's a whole lecture on this. If I have time, we can discuss this. If I don't, I won't. Or maybe next semester. What do you see here? Puri slabs or beams intact thing. When I was there, this was a picture I took myself. A lot of people died. Very bad smell over there. Horrible scene. It was very sad place. But I spent good 11 days there. We took samples. We did a lot of testing with the Sir Yaqub. He was my professor. He was a very intelligent man. He's now in USA, I think. Or maybe he's chairman Texla anyways. Khair, we lost contact. What this picture shows is that all the beams and slabs were intact. Some were not, some were. The failure of the column is extremely detrimental to the structure. So you don't want the column to come down. If there is a beam that has cracks, that is problem, that can be taken up and repaired and cured. But if you have a problem with columns and if they collapse, min fazle rabbi. Sorry, that's wrong. मैंने बोला बोल दिया नहीं पैसे कहाँ से आएंगे? So yeah. So basically, there was hinge formation and plastic hinge and a lot of things that we can study in next semester, not this semester. This is a lecture for a later time. Anyways, where were we? So columns. So columns have two roles. Columns will have two roles because they will provide stability against two kinds of forces. Columns have two roles. Did I tell you guys about gravity and lateral? Anything that is coming towards the earth is a gravity load. Anything that is coming in a direction which is perpendicular to the building is a lateral load. Lateral, whatever you want to call. If you're a British, lateral, whatever. So if this is my building, if this is my structure, let's say it's a 5-story building, it is the Comsat tower that we have over here, and we are sitting here, this is the floor that we are on, and suddenly there is earthquake. The earth goes like this, and we have a... Who is talking? It's very annoying. You? No, you know. You can't. I know. So if the first jolt comes, where will the building go? अच्छा ना? The first jolt. Now, I want you to recall a phenomena called inertia. When the car is still, and if it's a fast car, and it zooms, where do you go? In the direction of the car? Opposite direction. So you go, the building goes like this. What you are going to experience is a inertial force. Not equal. There's a lot of, that's a complicated mechanism. There are engineers in that who have their masters and PhDs in dynamics. कि कितना जाएगा और कितना आएगा, to and fro. Now, what I want you to bring now to your mind, and this is what we are taught even at MSc level, a pendulum. ठीक है? A pendulum. You swing it, it went here. Now this force this force, zalzala ऐसे नहीं है, building कैसे हिलती है? ऐसे? Left and right, left and right. What do you think? Zalzala is also left and right? Most probably not. Most probably not. This is probably a sinusoidal wave जो earthquake में create होती है. And it passes by very fast. What you experience is the to and fro vibration of the building. What you experience is this. Let's say I have a metal bob here. And this goes like this first. And then it comes back. And then it comes back. And then it comes back. And slowly and gradually it stabilizes. This, ladies and gentlemen, is called the harmonic motion of the concrete structure. This is the harmonic motion. It goes like this. So, a lot of engineers even think that the earthquake goes like this. आएगा जाएगा आएगा जाएगा. But no. When you study seismology in depth, like yours truly, you realize that when a tectonic plate vibrates or shifts, it dissipates like a tsunami, one wave, or number of waves, or maybe one wave. Let's see. So this wave passes by earthquake like this. This is the sinusoidal curve. You know this, right? Cosine or sine, yaad hoga. This wave passes by through very quickly. And we call this, the study of this wave, response spectra. It's the response of the building. If you look at a response spectra, the building responds like this. Why is it dissipating? So I'm here at the peak. ये तो वेव गुजर गई एकदम से, राइट? मेरी बिल्डिंग के साथ earthquake ऐसे आया कि एकदम से एक sonic boom जमीन में से गुजर गया. Now you are going to experience its aftermath, which is going to be a response spectra. ये maximum left to right चली गई बिल्डिंग, फिर ये वापस आई, फिर ये थोड़ा सा कम हुई, फिर ये थोड़ा सा कम हुई, फिर ये थोड़ा सा कम हुई, this and that, and it goes like this. So, whose name started here with F? What's your name? Fizzer? What the fizzer? No, I like fizzer more. Why is it happening? So the most of the buildings collapse during the first peak of the cosine wave. मतलब जलजले ने जिस बिल्डिंग को गिराना पहले झटके में गिराएगी. It is not कि जी दूसरे या तीसरे में कुछ होगा. So you guys are idiots when you're running out of the building. It's done. If it is going to come down, first wave, first jolt is the maximum. Maybe the second. Why? Because building loses all its strength on this, and when it has to come back, it does not come back. Running is stupidity. The maximum you can do is get into the table. Running is just a human behavior. But as a structural engineer, whenever I have experienced zalzala, I have said like, अच्छा यार पहली peak गुजर गई, zalzala खत्म, अब कुछ नहीं होता. The structure has resonated the most. So if you've survived that first jolt, then you don't need to move anywhere. Just look up at the beam. Are there any cracks? No cracks. Look on the right side. Are there any cracks on the column or not? Look on the left. Is there any man wearing white suit? These three things are not happening. यही होगा ना. नजर आती हैं चीजें मेरा ख्याल है मरने के करीब करीब. I guess that's the common belief. हाँ जी सलाम अलैकुम, चलो तैयारी पकड़ो. बड़ी ऐशी मचाई तुमने जिंदगी में. फिजा ने चीटिंग की है, तुम्हें तो मैं छोड़ूंगा नहीं. अंदर से गीली हो जाए वॉल. जी, that is the different problem. It has nothing to do with structure. Concrete is a porous material, just like your skin is a porous material. Do you know if you put anything, Aisha, do you put what do you call that? Base? Do you do that? The moment you put it, it just takes 1/3 of a second for that chemical to penetrate your skin, and it goes inside and does God knows what. All those chemicals. So use organic materials, Matti shatti leke malla karo muh mein. So that is what happens. It happens same to the concrete. It's an extremely porous material, just like your skin. The water splashes, it goes inside tiny veins. It stays there for a very long time. ये एक बड़ा problem है concrete. It's a porous material. Response spectra clear? Can I put this in the syllabus for asking you guys? कि जी एक बिल्डिंग का रिस्पॉन्स स्पेक्ट्रा बनाए. Although this is very advanced level things. I mean, a lot of engineers don't know response spectra. Khair, you are much more bigger and better than a lot of engineers, aren't you? No, you're not. The lecture is being recorded, so you will get to see everything, okay? So slide share करना मुश्किल है. Go back to the video. Anyways, ये पूरी कहानी राम कहानी सुनाने का मकसद क्या था? Columns are important. Earthquake में जो बिल्डिंग गिरेगी वो गिरेगी कॉलम्स की वजह से, बीम्स की वजह से नहीं, स्लैब की वजह से नहीं. It will be only because of the columns. If your columns are weak, your building has a problem. Now, if my columns are thin elements, if I need more calculated stiffness, what do I do? What do I do? ठीक है. अब मैं बहुत लेमैन टर्म्स में बेसिक तरीके से जब मैं इंजीनियर्स को पढ़ाऊं, तो दिस इज हाउ आई टीच देम. आई विल ट्राई समथिंग विद यू गाइस. आई हैव अ बिल्डिंग प्लान एंड इट इज समथिंग लाइक दिस. एक बिल्डिंग यूं है. प्लीज डोंट टॉक. साइलेंस. This mysterious voice coming from somewhere, I don't know who it is. 100 rupees for the more who tells me. You're really talking like my daughter. वो भी यही करती है. मुझे 1000 रुपए देंगे तो फिर मैं बात बन सकती है. Anyways, so you have a earthquake force building design from this side. I say this Fx. Remember Fx? And since we are in the plane, हमने बिल्डिंग के प्लान में है, मैंने बीम्स नहीं बनाए. And we have an earthquake, maybe we don't know कि earthquake ने यहाँ से आना है या 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 यहाँ से आना है. So we design for the maximum. Now, अब इस बिल्डिंग की मेरे पास देखें कितने सारे कॉलम्स हैं. Let's say I have all of these columns in this line. It's a thin cylinder building. So I have a lot of columns in this direction, right? To resist the earthquake. So if the earthquake comes here, I have like the 1, 2, 3, 4, 5, 6, 6, 7, 7 into 3, 21 columns are going to resist this. Got it? Now, if my earthquake force passes through this line only, how many columns do I have here to resist? 3. मैं कहता हूं चलो ये भी contribute करेंगे तो what? 6. I'm in trouble. I have a problem. अगर मैं कहता हूं कि this is a 100-ton jolt and this is also a 100-ton jolt, I have a problem here. How do I solve it? How do I solve it? I solve it by putting a very big wall. Yes. I solve it by putting a very big wall here, which is going to be equivalent to all of these columns for a 100-ton load. So now I then superimpose this force over here. Again, I see now this is contributing, okay, but then maybe I need one here as well. And maybe I need one here as well. This is just to give you a concept what shear walls are for. What are the problems that engineers face? कि आपने एक पतली सी बिल्डिंग डिजाइन कर दी आर्किटेक्चरली लुक्स वेरी नाइस बट आई टेल यू कि यार इसकी तो कैपेसिटी ही नहीं है एक्स डायरेक्शन में वाई में तो इट इज वेरी नाइस आई डोंट नीड अ शीयर वॉल हियर बट देन आई टेल यू कि यार एक्स में तो ये है ही नहीं है ये दिस इज गोइंग टू कम डाउन एंड देन यू टेल मी आप किस काम के इंजीनियर हैं जाए मैं आपको पैसे नहीं दे कोई और ले आऊंगा कोई और फिर मिल जाता है कोई ना कोई उल्लू का पट्टा वो कर भी देता है डिजाइन हो जाता है वो आई हैव एक्सपीरियंस दैट इन माय लाइफ मेनी टाइम्स वो बिल्डिंग भी खड़ी रहती है पता नहीं क्यों. But yeah, buildings don't fall, they just fall one fine day, you know. If you don't wear your seat belts, there is a chance that that particular day, 1 out of 3,000, you will have an accident. So the statistically speaking, every time you wear a belt, you're safe against that 1 out of a 3,000 chance. Marginal Tower was built in 1991 and for 14 years it was pretty okay. सिर्फ बातें थी कि जी ये है वो है one very wrong day after 14 years it went out like that. So bad engineering doesn't show up every day, it will show you one fine day, one very not fine day. सही है? So now you know what shear walls are for. So now if I have a building like this, and the architect wants me कि जी जिशान साहब बात ये है कि मेरे कॉलम्स का साइज छोटा होना चाहिए, दे शुड नॉट बी मोर देन 12 इंचेस. मैं कहता सर ठीक है, बट देन आई वांट कि मुझे शेयर वॉल दें, दिस टाइम आई वांट दिस इन बोथ द डायरेक्शंस, लेट्स से. सो द आर्किटेक्ट वुड से अच्छा करें सर आप इस तरह करेंगे, ये जो दरमियान में जो आपने लिफ्ट वेल बनाना है ना, आप ये शेयर वॉल बना दें. नाउ आई हैव शेयर वॉल्स बोथ इन yes, X and Y. Okay, so now my building is strong enough, it's sturdy, it's in the center. It's just like if you want to get a feel of the shear wall in the center, let's say I have, मैं गत्ते की slabs काट लेता हूँ, एक और फिर इसके नीचे एक और, तीन, सिर्फ simple paper, you can experience the shear wall effect in the center. मैं अगर एक स्टील का पाइप इनके दरमियान से गुजार दूं, imagine now, can you get that? How that shaft in the middle will provide sturdiness. Get my point? While on the subject of shear wall, I like to touch high-rise buildings a little bit. मैं 1000 रुपए देने को तैयार हूं. कौन है ये? जी जो लगा हुआ है. Please, हाँ please rat him out. कौन है? So now, this is a building, this is the Gacken Spiral Tower, right? When you want to do these kind of high-rise buildings, when you want to do these kind of structures, the most important thing is, again, look at this building, look at these buildings. What do you see here? A central shaft. It could be made out of concrete, it could be made out of steel. Forget this. Right now I want to show you something. This is a very nice research paper, by the way. There. Central column. So you can perceive the shear wall as a very huge, hollow, circular column or rectangular column or a square column. सही है? Column जरूरी नहीं है कि solid ही हो. If I can say कि अगर आपने बिल्डिंग का कॉलम आपने ये बनाया है ना सॉलिड, हाउ अबाउट आई मेक अ कॉलम लाइक दिस, विल दैट वर्क? दिस इज ऑल्सो अ कॉलम. सो taking the analogy of those plates and then putting a solid steel shaft in the middle will give you a feel of something like this. से बुर्ज खलीफा इज द सेम थिंग. सो यू हैव अ वेरी, लेकिन प्रॉब्लम क्या है ऐसे हाई राइज बिल्डिंग्स में, डू यू नो, सारा चीजें, सारे का सारा स्ट्रक्चर माल खा जाता है. 30% of the 40% of the spaces are taken up by the structure when you want to go high rise, and you get 60% of the floor plan, which is, I don't know, it's a call, maybe building. आप लोगों ने आर्किटेक्चर हिस्ट्री पढ़ी है अभी? पढ़ी है? उसमें एक बड़ी इंपॉर्टेंट चीज आएगी. आई डोंट नो वेदर दे टीच यू और नॉट. व्हाई डू ancient civilizations created massive structures? Why? Why were pyramids made? Why was the Tower of Pisa made? Why were these things made? Why is Taj Mahal there? Why? Very good. That's the right thing. Why do you need Burj Khalifa? Do you mark a mark on everybody कि हम ये हैं? We are powerful. Please come here. Finance. Put up your industries here. Bring foreign investments. Do that. That is why you invest in infrastructure. Something Khan Sahib really believed did. What? Sheer walls as bigger columns, but walls. Okay? I think so. Yep. जी क्या ख्याल है आपका? नहीं नहीं नहीं. जी मैम. जी. यस. लेट्स नॉट गो देयर. उसमें बहुत कॉम्प्लिकेशन है. दैट इज अ वेरी, I mean, that's a call of engineer where he wants to pin them and where he wants to fix them. But the answer to your question is yes, they can be both. Scenario to scenario, there is a difference. If I'm doing, let's say, a hollow core slab system, then they're going to be pinned. If I'm doing a SMRF, special moment resisting frame, OMRF, then they have to be fixed. So they can be both. So there you go, that's your typical column. You've already studied this. You have main bars, they will always be odd in number, right? Even. किसने कहा even? Very good. See? Even number. They always have to be in even number. You can't have odd number. They look stupid. That's the only reason. Otherwise, you can have odd number. I think I'll try a column with odd number someday when I feel really funny or I am about to die or something. Yeah, डाल देते हैं इसमें 5 सरिये. Let's live live on the edge and have a doobie and just put 5 bars in a column. That's it. that's your typical column, okay? 4 bars. Then there are shear bars which are, अब उनको आप lateral ties कह लें. Engineers like to do that, मोटे मोटे नाम रखें, but they're basically shear bars. वो ऐसे नहीं, ऐसे थी, ऐसे होगी तो उनको lateral ties कह देते हैं. वो ऐसे हो गई तो उनको shear bars कह देते हैं. The same thing. The detailing aspect, again, you know that 412 mm dia bar will be, हम जो ASTM में कर रहे हैं, क्या होगा नंबर इसका? मैडम, why am I seeing these faces first time in my life? You are here again in this class first time? Okay. क्या होगा? You acting like your first time. क्या होगा नंबर 12 mm dia कितना बनता है? Let's say ½ inch चाहिए. ½ inch dia का क्या नंबर निकलेगा? हाँ जी, टॉपर मैडम. नहीं कर लिए तुक्के के साथ टॉप. ½ inch डाई का क्या नंबर है? नंबर 4. सही कहते हैं. ½ inch डाया विल बी नंबर 4. व्हाई? मैं उससे पूछ रहा हूं, इससे जरा बताओ. ये मैडम ये नहीं बोलती. ये भी तुम्हें आवाज सुनाएगी अपनी. जी हो ऊंचा. क्या होगा? Why is it number 4? Divide what by 8? What do you divide by 8? What is the paper पे अभी कैलकुलेट करके बताओ. What will be the diameter of a number 6 bar? जल्दी जल्दी जल्दी. I don't have time. I have to finish this lecture. आता है या नहीं आता? बोल दो. क्या? क्या? 6 बार ले? क्या? तो हाँ, वेरी गुड. क्या निकलता 6 by 8? जल्दी. 6 by 8 क्या निकलता है? go. ठीक है? The third thing is slab. And I told you in the very पकड़ लिया मैंने तुम ही हो ना. The third most important part of an RCC is fourth actually shear wall, columns, beams, and slabs. So I told you in the very beginning in the in structural elements we have two things: plates and elements, line elements. Right? This is the plate. It has a different behavior altogether. It is designed something else, but eventually it's a plate. You can put people put even अगर आप इसके ऊपर metal deck डाल सकते हैं, लकड़ी का deck डालना चाहें डाल सकते हैं. It's just a plate. So the plate should be strong enough itself and strong enough to transfer the loads it take to the. तुम्हारा it's a lucky day today by the way. क्या होगा? Where do you do that? Slab उसको खुद नहीं पता जो फाउंडेशन बोल रही है, गलत बोल रही है. क्या होगा? So slab take load and they should be strong and fill in the sentence. Slab should be strong enough to transfer the load from slab itself to I'm asking her why are you saying? I mean I don't understand. How is that comprehensible? And take your fingers out of your mouth. Thank you. क्या होगा? और करो टॉप. Huh? Yes, who said that? Good. अभी मैं बोल बोल के थक गया हूँ. Slabs to beams, beams to columns, and columns to foundation. Next class, sit here with these people over here in the front, okay? So slabs will take the load जो आप लोगों का है, जो ये डेड वजन है, जो धरती का बोझ, वो स्लैब पे जाएगा. स्लैब से कहाँ जाएगा? बीम से कहाँ जाएगा? यस. और फाउंडेशन से कहाँ जाएगा? सबस्ट्रेटा. Types of slabs, we have cantilever slab, we have two-way slab. This is important, very very important. So we have two kinds of slab, and the entire scenario changes, the entire building type changes when I have a different types of slab. So I have a slab beam here, beam here, beam here, assuming this is all a perfect square, okay? And I have a slab in the middle. How is drawing slab funny? Please let me know. Why are you giggling on slab? Does it rhyme with something? Slab, blab. Then why would there be laughter? Crab. Nope, no dirty word I know of. Then why giggle on slab? Hey? Enlighten me. It doesn't. Anyways, so this is the slab. I still don't understand why slab is funny. So this is, let's say, diminishing. So I would say this is, let's say, L, and this is W. When L divided by W, oh no, there's a shorter span and longer span, okay? When the longer span divided by shorter span is greater by 2, it's a two-way slab. Okay? And when L divided by S is less than 2, it's a one-way slab. So I would draw, now for the sake of example, I'll draw a one-way slab and a two-way slab for you guys. So according to the rule, now this and this, if I say this is 30 feet and this is 8 feet. Let's say 10 feet. And I say this is 24 feet and this is 40 feet. So the shortest span is 10 and the longer is 30. 30 divided by 10 is less than 2 or greater than 2? Greater than 2. So this is a one way. If the ratio is greater than 2, it's a one-way slab. मैंने बोला था, क्या बोला था मैं माजरत माफी मेरे बाप की तौबा. It's a one-way slab. मैं बहुत शर्मिंदा हूँ. बड़ी मेहरबानी, आप लोगों का बड़ा दिल है, माफ कर दें मुझे. It's a one-way slab. ना करें. सही है? Now this, the longer span is 40. So 40 divided by 24 क्या बनता है? 4 ये आ गया जनाब 6 and 10 and 3 and 5 and 5 divided by 3 is something like I think 2.666. Sorry, मैं फिर से माजरत चाहता हूँ. 1.66. So it's less than 2. This is a two-way slab. Okay, makes sense? Why do we do these? Now the problem is with the one-way slab and the two-way slab is that this slab will put the load on all the beams. This beam, this beam, this beam, this beam. I hope you guys remember that there are beams here, right? These extremely mentally retarded beams. So the load is transferred to the beams. So this is two-way. It's doing it in two ways. It's doing it in XX and it's doing it in YY. However, this only transfers in one direction. Like the band. Whose singer died, by the way, ना? जिसने छलांग मार दी थी ऊपर से. One direction था ना वो? One direction. ठीक है? So look at this slab. Look at this slab. Is this one way or two way? How many of you think it's a one way? Be discreet. Yes or no? This is a one way slab or a two way slab? That's fine. I just taught you. If you're wrong, there's nothing wrong with that. You don't get the point? There is a point. I'm coming to that. Just try to identify first. One way or two way? How many of you think one way? Please pull your hands. I should see your armpits that high. How many of you think it's a two-way slab? Okay. It's a one-way slab. See, that could be what? 8 feet, 10 feet? This is pretty much 40 feet, I think. 35 feet. So 30 divided by 8 or 10 is 3 above 2. ये स्पैन तो ये है ना बेटा. स्लैब का स्पैन कहां से कहां तक है? स्लैब का स्पैन बीम टू बीम होता है. स्लैब का स्पैन बीम टू बीम होता है. Now, where to use one way and where to use two way is again the discretion of engineer. This engineer, for some weird reason, or maybe it's his way of doing things, is using one-way slabs. I would have not. But I would have had actually, because he's distributing a load. I think it's a good design. It's a good structured design. He's distributing the load on a lot of slabs, and then he has maybe primary beams going from here to there. But then how come the column is here? Maybe not so good engineer, I guess. But then major column should be here then. Should be here somewhere then. Actually, you know what? Look at that column outside. वो जो बाहर है. That's an L shear wall. It's literally like... So, let's look at this room's structural configuration. So the engineer's discretion was, I need bigger rooms. Client was Comsats. They said, we want bigger halls for the students. So engineer saab, hame make me a hall of, let's say, this is pretty much actually, I think, 60 feet. No, this has to be at least 55, 56. Count the tiles. Fizza, count the tiles. From there, खड़ी हो जाओ, आगे गिनो सारी tiles. यहां तक गिनो कितनी है? आधी है ना, डबल कर लेंगे.
30.
Are you serious? 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10. 10. This is almost 36 feet. Say, so the client says, I want a 36. As I said to you, this is a pretty big span for concrete, by the way. Say 36 by, again, I think 24, let's assume. Yeah? 24 feet. So what he did was, he said, okay, this is a pretty big room. I will put my slabs here, beams here. These are my beams. And the beams take the loads to the columns. But I can't have a column on every corner, can I? Maybe I can, maybe I can't. I don't know, I can't see something. This could go either ways. This could be that there are columns here, like this. The slab is a one-way slab, load here and here and here and here. And then these beams take that load and put it over here on this column and on this column. This is one way of doing things. Otherwise, what can happen is that these red beams can become secondary beams, and then I can have much bigger beams. I can call them primary beams and take load to the 4 columns on the edges. But they have to be then big columns. Right? So let's see how the load is flowing. So the slab load comes to here and here. Then this brings to this big beam here. These columns are not here. And then this big beam takes it halfway here and then halfway here. And then obviously then you have that going to the ground. Isko hum kehte hain load path. We need to provide load path to the building. So until unless I don't see the drawings of the structure, the way it looks like that there are columns in every wall, small tiny columns maybe. And if they are not, then what I see is a big shear wall at the end, like this. Mind you, shear wall can be an L shape as well, or even on a T shape, and even I shape. A lot of shapes can be shear walled. Let's not go there right now. Okay. So now this is going to be the question. I'm telling you, one-way slab and two-way slab. Yaad rakhna. Here's the trick. Lecture is recorded, go back and look at it, okay? No, Modi, don't. Okay. So, though I have slabs, there are continuous slabs, there are discontinuous slabs, not of much importance to you guys. You know the cantilever beams भी होती हैं, cantilever slabs भी होती हैं. Overhang beams भी होती हैं और overhang slabs भी होती हैं. So it's pretty much the same thing. Still something not worth mentioning to you. You know the distribution. Do you see what's happening here? Where is he taking the bar up top? नजर आ रहा है? ये. What is he doing here? What he's doing here is, we in the modern way, we detail slab. ये bottom steel आ गया and ये top steel आ गया. Right? पुराने ज़माने में, like I'm talking 80s and 90s, what people used to do is, कंजूस तरीन लोग होते थे, they would take this bar and bend this up and to this negative bar. Not anymore. People don't do this anymore. अब हम लोगों के दिल बड़े हो गए. Because it takes a lot of time. आप इसको पकड़ के bend करें और फिर यूं करें. So time is now money. At that time there was no money and a lot of time. Yeah. So आराम से लेके लगे रहते थे यार सीधे इन्हें पुट्ठा कर इन्हें सीधा कर. So you can bend a bar and save a little bit of steel. But since no more shidas, no more bending up. It's just like this. But if you look at it here, this diagram, This is what he has done. He's taken a positive bar. Positive bar कहाँ होती है? कहाँ होती है? कहाँ होती है positive bar? हेयर स्टाइल में तुमने बड़े झटके लेके संभाला है. What is positive bar? Were you there in the class last lecture? You were not. Good. Positive bar कहाँ होती है? Bottom. So the positive bar is at the bottom and the negative bar is at the top. Now to the most ending lecture this is a very long lecture yaar. 57 slides musibat. I'm sorry this has to happen because I don't have a second time to do this then. Already itni sust class hai ye. So we have two kind of foundation. Now we have a question here as well. Okay? In the exam. Let's now discuss the foundation systems that are made in concrete. And all over the world, 99.9% of the foundations are in concrete. Steel structure की foundation भी concrete में होती है, concrete structure की भी concrete में होती है, even timber structure जो बनते हैं उनकी भी concrete में ही होती है. So concrete की foundation में you don't have any other option in the world so far. It's concrete, concrete, concrete. So I can divide this concrete foundation. The short form of the foundation I will use in the lecture is FND. Okay. I have two primary types. Shallow, like some gentlemen here, and deep, like myself. And how is that funny? And I'm sure she's saying right now, deep. मुझे पता आप कितने deep है. So anyways, so we have deep foundations, and as the word says it itself, if this is the strata, I have very high bearing capacities here. You know what a bearing capacity is? Let's discuss that. And I have normal bearing capacity. If I graph this, if I go, this is D, depth, and this is BC, bearing capacity, nothing else. It increases as depth increases. So the bearing capacity increases as depth increases. Can you please stand on one of the tiles here? Now, these tiles that this guy, bilkul iske andar, not outside the tile. So I have this tile which is 1 feet by, please pay attention to this. ये bearing capacity है आपको contractors और engineers बताएंगे और उसके बाद आप सर खुजा रहे होंगे यार ये क्या होता है? Bearing capacity क्या होती है? Let's say this tile is 1 feet by 1 feet. What is your weight? 64. He's standing on what? 1 feet into 1 feet? And nothing is happening. Static equilibrium is there. Summation of f of y is equals to 0. So it has a bearing capacity. Assuming we are on soil right now. Okay? We're not in this building. He is standing. ये बाहर ग्राउंड पे खड़ा हुआ है 1 feet by 1 feet के ऊपर 64 kg per SFT. Why am I not saying 1 SFT? Because it is one, it's unity, so it's always 1 SFT. So SFT. So 64 SFT इसकी bearing capacity है. Can somebody else stand with you on this? Let's assume for a while. हमें ज़रूरी नहीं है कि बिल्कुल हर चीज़ illustrate करें. Let's assume. Thank you. Do you want me to stand here for a while? Keep standing. It makes things easier. Thank you. So let's assume, what's your name? Iftikhar is 1 ton heavy now. He is 1 ton now. And this is 1 SFT, 1 feet by 1 feet. So I say, let's say 1 ton. And he's standing on SFT. When I say SFT, that means how many SFTs? Miss Bubblegum? Did you tell her? You just said this to me. Pay attention. Don't talk, please. This is important for you. I know you hate me. I can see it in your eyes. Yes, you do. But pay attention. I know who hates me. So yeah, you're one of them. Say it. Now, he is 1 ton. He's standing on 1 SFT and nothing is happening. Can I say the bearing in the terms of English capacity is 1 ton per 1 SFT or SFT? ये होती है बेरिंग कैपेसिटी. ठीक है, समझ आ गई बेरिंग कैपेसिटी की? नहीं आई? किसको नहीं आई अभी भी? I can go again because this is coming to haunt you again and again and again. हाँ? कैपेसिटी मतलब आप एक जमीन पे 1 फुट के हिस्से पे खड़े हो गए. अब जियोटेक इंजीनियर करेगा कि जी इसके ऊपर 1 फुट पर स्क्वायर फुट पे आप क्या ना, स्ट्रेस का फॉर्मूला क्या है? फोर्स ओवर एरिया. एरिया कहाँ है? ये. सो बेरिंग कैपेसिटी इज नथिंग बट अलाउबल स्ट्रेस. अब समझ आई? बेरिंग कैपेसिटी इज द अलाउबल स्ट्रेस. अब मैं ये कहता हूं कि जी अलाउबल जियोटेक स्ट्रेस इज 1 टन पर एरिया आ गया ना. 1 SFT, as I said, I will not say 1 ton per SFT is the bearing capacity of this soil. तो आपका कॉन्ट्रैक्टर आपको आके कहेगा कि जी इस बिल्डिंग की जी ये जियोटेक रिपोर्ट है एंड द बेरिंग कैपेसिटी इज 2 ton per SFT, 3 ton per SFT. अब I have to make a high rise building. Thank you. I have to make a high rise building. And my calculations tell me that my load under 1 column is coming out to be 1000 tons. This happens. It's a practical example. The bearing capacity I have is 2.5 ton per SFT. What do I do? What do I do? As I drew a graph for you, it's a very simple graph. If this is bearing capacity and this is the depth of soil and this is the curve, what do you deduce from here? ये उठाओ इस ईयर को चपेट मारो के रख के इसके मुंह पे. लेक्चर चल रहा है, क्यों सो रहे हो? हाँ? You can go out of the class if you want, but don't put your head down in my class. I hate people like that. नींद आई रही है. एक्सटेंशन में तुमने अपनी मर्जी की ले ली, सब कुछ तुमने अपनी मर्जी का करवा लिया, तो क्लास में तो अटेंटिव बैठो. रात को फोन पे लगे रहते हो, सुबह क्लास में आ जाते हो. What does this imply? Miss, I take your lecture very seriously. Look at the curve. It's pretty mathematical. This is D, depth. Depth माने 5 फुट, 6 फुट, 7 फुट, 100 फुट, 2 फुट. This is. So what is it? This curve showing? हाँ, की बात होगी. जैसे जैसे सॉइल ज्यादा होगी तो वो तो खड्डा ऊपर आता जाएगा ना. तो हमने तो नीचे जाना है. क्या करें? मट्टी डालते रहे ऊपर उसके. We need to go down. So this curve implies as you go deep, you get higher bearing capacities. It would have like, I'm just imagining 6,000 tons of load on 1 column. So obviously we can't put it on the 2.5 ton bearing capacity. Can we? So what do we do then? We go deep. So isme, now if I categorize the deep foundations, I have piles. Piles are literally screws, very long, strong screws I drill into the ground and I go 200 feet, 300 feet. So what happens is that I have a pile cap. This is the pile cap. I have a column on top. It's a mega column. It's, let's say, 6 feet by 6 feet, and it has a load of Burj Khalifa of 6,000 tons. What do? I can't put this on soil. The soil will collapse there and then the building will sink into the ground, hence achieving a non-static equilibrium. So I take all of this load, I distribute these, and I drill in the ground piles and take them as deep as the geotech report tells me, where I have a bearing capacity of, let's say, 300 tons per SFT. So I take this load and I drill this down deep to the ground, and I take it to the strata, which is down there, 300 feet, 200 feet. Make sense? Generally speaking in Pakistan, out of my experience that I've seen, anything above 15 floors poses that you will have to go on piles. If you have a bearing capacity less than 1.5 ton. So what do I have to do? I don't have any other option. I take the whole loads down, transfer them deep into the ground. Making sense? Or do I give an assignment on this? ठीक जो ये कहे make sense? ये समझ में आया कि नहीं? This is very important. This is going to be a part of your question. I'm going to give you this time a question from the foundation systems. So actually D foundations are pretty straightforward and pretty simple. You have piles, you just transfer the load. Like that. Okay? In piles, we have end bearing piles, we have friction piles, and we have compaction piles. Compaction piles are barely used. So let's stick to this too. End bearing piles. What does end bearing pile mean? That I have a pile, it takes load on the top and simply transfer to the end. Then I have a friction bearing pile. What does the friction does? जाहिर सी बात है, इसका एक सरफेस एरिया है, ये इर्द गिर्द इसके सॉइल होगी, and it will have a coefficient of friction, and F is equals to, say that out loud. बोलो, be confident. सही बोल रही थी. बोलो. Mu R. So this resistance, and if you have the value of U, let's say 0.3 or 0.4, it's a coefficient, adjustment coefficient. So it's between 0 and 1. Yes. You know adjustment coefficients. No, you don't. Adjustment coefficients are adjustables, regressional analysis or invert regression analysis. Their value is always from 0 to 0.1. So if I have 6,000 tons coming down, force, I need a reaction of, if I have mu 0.5, I need a reaction of, yes, who said that? CV is welcome again. 12,000. Because multiply that by 0.5 and you have a R, this resistance 6,000. And then you need this surface area of this pile कि ये friction इतना उसकी friction हो कि वो resist करे और वो करे. So before showing you that slide, I would show you this slide. Right? This is the friction pile. Do you see the arrows going up? Because it's going to do it from the surface. I hate these kind of piles, to be honest. I don't want to rely on a friction coefficient and base my entire calculation on friction coefficients. I like end bearing piles. They are much more safer, they are much more calculate. What happens is कि मैं 6 का 6 टन लोड जो है, जो मैंने यहाँ डाला ऊपर, मुझे यहाँ पे मैंने रिएक्शन ले लिया. And as an engineer, ये जो रिएक्शन है फ्रिक्शन का, it comes to me as an added benefit. So the piles I personally like are a mix of these both. I like to do friction / end bearing piles. That's my personal preference. Nobody else does it. I do it. And it gives me a sense of economy as well. ठीक है? And we are not going to discuss these kind of piles because in the chapter of Pakistan they are not very common. Or maybe they are, I don't know about them. Right? Let's look at friction piles. So, how they are done? Okay. Yeah, sure. Can you hold your pens in your fingers like this? As tight as you can. All of you. Right? Can you apply, let's say, 20 kg of force to it? So your hands are over here and the pen is in the middle. You're pulling it like this. This is the right diagram for explaining this thing, this phenomena. Why is the pen not coming out? Friction. So what is the direction of the friction? Opposite to the force. So this is R. Now hold this as tight as you can. And if it is very tight, then I would say the value of mu is 0.8. Now loosen it up so much that it scratches and it comes out. Then the value of mu is 0.1. अब समझ आया? समझ आया? The surface of your hand and the pen or this, let's say this finger, how is it stopping it? कोई आगे चीज तो नहीं लगी हुई ना? It's stopping through what? Friction. Same thing again. If you're pushing it inside, it's the same thing. The friction, the surface friction. Now the thicker finger I have, the more surface area and more the friction. So there are two things it depends on, na? The surface area and the coefficient of friction. कि ये मेरे हाथों की लकीरें कितनी गहरी हैं या नहीं है या बिल्कुल ही फारग है. Or I can do is I can oil this to reduce the friction. That is the lubrication will reduce that friction, and then the penetration of the pile or anything, it will reduce the coefficient of friction. Or you can use a ball bearing. Also, the ball bearings will reduce the coefficient of friction. What else can you do? You can reduce the contact. So contact area, maybe bearings. These are the aspects that reduce the surface friction, the contact friction. It's a very important part in engineering actually. Even in the concrete beams and everywhere else. Friction has a very big role to play. Friction pile समझ में आ गई है? So what do you do? How do you do this? You have this thing called KCN. How will you put a friction pile? Or how will you do a piling system? How will you do a piling system then? If this is my, let's say, piece of land और मैंने ब्रिज बनाना है और समंदर के दरमियान बनाना है, so I need foundation. It has to be deep foundation. I can't put my foundation on the floating land. So what happens is that there is a boat like this. मैं अब ये समंदर की एग्जांपल दे रहा हूँ, लैंड की ऑटोमेटिकली समझ में आ जाएगी. So I have a boat. This boat has a hole in the middle. What we basically do is we have जैसे hollow shells होते हैं. You dip them down in the ground. These hollow caissons go here. एक केसियन डाला तो अगला कैसे डलेगा? इसके ऊपर रख के you hammer it down. Just like you would do it to maybe वो mechanical system है, एक bush system कहते हैं, bushwhacking कहते हैं इसको. So you press it with the hammer, hydraulic press, and these caissons keep on pushing each other. 20 फुट का एक डाला, फिर 20 फुट का एक डाला, फिर 20 फुट का एक डाला. You keep on pushing them, while till the time, let's say, you have hammered them on that board and you're all the way here. And I'm saying 300 feet. You de-water, पानी बाहर निकाला, and then you put in what? What? Concrete. Because this is made out of concrete. Not only concrete, R concrete. RCC, not R concrete. Got it? And that is how piles work. And then you can lift the column of your bridge and pier जिसको कहते हैं. And that is how. Then you have your beams and then you have your slabs and everything goes up. Pretty ABC. क्या मुश्किल है इसमें? So you have your well or casing foundation. Well होता है अगर आपकी pile 30-40 फुट की है तो you can simply dig it and put concrete in the sand, soil. My question here is very technical now and let's see आपके साथ होगी जितनी होनी थी. My question to you, sir, start up, is if I have a Kasian pile foundation, can I design it as a friction pile or not? Can I design a Kasian filled pile? Kasian filled क्या होता है? Kasian क्या होता है? Kasian क्या होता है? अभी मैंने बताया. Steel का hollow shell. Can I design it as a friction pile? बैठ जाओ. हाँ जी. Can I design a Kasian pile as a friction pile? Can I design a Kasian pile as a friction pile? Proper? हाँ. क्यों नहीं? Excellent. Very nice. He is the only person who's alive here. उसका कॉन्ट्रैक्ट किस कंक्रीट और कॉन्ट्रैक्ट सरफेस सॉइल के साथ कैसे होगा? बीच में तो मेटल है. Until unless you don't have the well foundation का मतलब है कि आपके मट्टी के साथ इनका कांटेक्ट है, तब तक तो आपका फिर वो सॉइल फ्रिक्शन पाइल हो ही नहीं सकती. So this could be a question कि जी in a building scenario के steel Kasian piles were used. Can they be designed as friction piles or not? Conceptual questions. इतनी परेशान क्यों हो तुम आज? और everything okay? Good. So that's that. I think we should curtail it over here and not go anything else. Just give me a minute. Hold on. एक second. Shallow foundations. Shallow foundations are pretty simple. They are spread foundations or isolated foundation. हर कॉलम के नीचे उसकी foundation. This is for low loads. एक स्टोरी 2 स्टोरी से ज़्यादा मैंने नहीं देखा कभी isolated foundation चल जाए. जब इससे ज़्यादा होती है, this is shallow foundation. I think we can continue foundations in next lecture. This is going to become very long. Then very difficult for you to absorb. हैं? समझ में आया सब कुछ?